Dear students and viewers, welcome to my channel Vinay Kumar Basics of Physics. In this video, you are going to learn about conversion of moving coil galvanometer into voltmeter and comparison between ammeter and voltmeter. Senior in physics. After watching the video, like, share, comment the video and subscribe my channel. Let's go for the topic. Hi children and viewers. In previous video we discussed about the how we can convert a moving coil galvanometer into the ammeter. That is the one of the best or most important question for 8 marks in our public examination. In this video I am going to explain one of the another topic that should be related to the moving coil galvanometer. In this video, we are going to learn about the conversion of a galvanometer into a voltmeter. How we can convert a moving coil galvanometer into the voltmeter. Let's discuss. Children, I already uploaded 2 videos, one for working and construction of moving coil galvanometer and second one is how we can convert the MCG into ammeter. So up to now you didn't see those videos. I will provide the links of those 2 videos in this description of this particular video. Children, after completion of this topic we will go for comparison between ammeter and voltmeter. Write the differences between the ammeter and voltmeter. That is the one of the most important question for 2 marks. Clear? That's why this is the one of the important topic. That's why you have to watch the video very carefully. Clear? So let's go for that. Okay, first thing, what is voltmeter? What is voltmeter? Voltmeter is the device that should be used to find out potential difference between 2 points in a circuit. So all of you know what is the unit of potential? Volt. So you have to remember very simply, voltmeter, volt is the unit of potential. That's why voltmeter can be used to measure potential between 2 points in a circuit. Clear, children? Okay, already children we know that. Look here, according to Ohm's law, what we write? V is equals to IR. I mean here potential difference is equals to current into resistance. Clear? Children, if you are connected 1 voltmeter in a circuit, then that particular voltmeter do not affect the amount of current that should be passes through the circuit, because what is the purpose of using a voltmeter? That should be used to measure potential difference. While we are measuring the potential difference, that particular voltmeter do not alter the amount of current that should be passed through the circuit. So to understand simply, I will go for this one. V is equals to IR. From that what we are, children? I is equals to V by R. If you can imagine V is constant, then what is, children? I is proportional to 1 by R. Here V is the potential what we are going to measure by using some voltmeter. So that should be here taken as constant. Then what we say? I is proportional to 1 by R. How these two are? These two are in inversely proportional. The value of R what we selected, that should be, if it is more, then the current will be less. That's why here the voltmeter must take small amount of current. That's why here we have to take the R is very high. That's why the voltmeter should take the very less current. Actually, for an ideal voltmeter, the resistance is infinity. So but in practical there is no device that should be having infinity resistance. That's why what I have to say, infinity resistance means that do not takes any current, but voltmeter must be required some current to show the potential difference. That's why here in practical volt ideal voltmeter is not possible. Okay children, so now I am going to the topic here children, how we can convert MCG into the voltmeter. Let's go for that. Okay children, here, so children, this is a one galvanometer that should be having some resistance G. Simply I am showing like this, this is the G galvanometer resistance. So for that we are added some large resistance. We are adding some large resistance. So this is the galvanometer and this is the high resistance value. When a high resistance value is connected in series with the galvanometer, then galvanometer is converted into the MCG is converted into the voltmeter by simple connection like this. Children, for 2 marks question also it is there, how we can convert MCG into voltmeter. By simply we are adding, how we are connecting the high resistance value of a resistor in series with the galvanometer. Simply when a high resistance of a resistor should be connected in series with the galvanometer, then that particular galvanometer should be serves as voltmeter. Got my point? So for the 2 marks question is there. Simply galvanometer is connected in series with the high resistance value of R. Then obviously MCG is converted to the voltmeter. So children, in this case what you have to say, G and R both are in series. Now it is a voltmeter. That particular voltmeter should be connected. So here if we can take them as a system, now it is the voltmeter. This is what? Voltmeter now. Combination of G and R. How these two are? How these two are? Series. Here the amount of current is passes through this one is Ig. And that means simply it is having only one path. That's why the amount of current that should be what it is entered, that should be G, again that should be coming out like this. So in this way we will say that galvanometer is converted into the voltmeter like this children. This is the first thing. And this entire voltmeter now it is connected in parallel to the circuit. Clear? In this diagram you have to clearly observe, this is the rheostat and this is the plug key and this is the battery, and here V is the potential what we are going to measure. Children, now this is the voltmeter, the circle what we are showing, this is the voltmeter that should be connected here in between A and B, in between A and B. That means what? We want to find out the potential difference between 2 points A and B. That is what we are going to be find out, that should be taken as here V. Clear? By using that voltmeter, simply here V is the potential what we are going to measure by using some voltmeter. Children, from that battery there is some current, it is coming I, that should be moving like this. At this point the current should be here taken as Ig, and this should be again going to the Ig, and this should be again I. Clear? So simply here in this diagram I am going to say simply here the voltmeter what we are taken, that should be connected in parallel to the other components or in parallel to the circuit. Clear? How it is converted? Simply when a high resistance value of resistor should be connected in series to the galvanometer, then the galvanometer can be acts as voltmeter. Clear? This voltmeter is again connected in parallel to this circuit. Clear? And children, now in this case, here you have to write. So what we write, children? V is the potential. V is the potential. What we have, this is the potential we are going to measure. Generally what we write, V is equals to IR. V is equals to IR. So generally in this case now we are writing V is equals to I into, here these are the two resistors. One is the value is R and when is the, sorry, this is the R and this is the G. Galvanometer resistance is G and it is the R. How these two are? In series. In series combination we are going to write here R plus G. Clear? Children, all of you know in series combination R is equals to R1 plus R2 plus R3 plus and so on. Here R is the effective resistance. Effective resistance, R effective is equals to R1 plus R2 plus R3. Clear, children? So by using that relation we are going to write V is equals to I into R plus G. So here I is nothing but Ig. The amount of current what it is passed to the galvanometer, that should be here same thing. Then what is, children? V is equals to Ig into R plus G. From that, here we are going to write V by Ig is equals to R plus G. R plus G. From that, what we have to write, children? The value of R should be written as V by Ig minus G. So this is the value for R, what we are added to the galvanometer. R is equals to V by Ig minus G, children. Okay? And children, here in this case, if the potential is taken as up to Vg, if the potential limited up to Vg, then what you would write? Vg is equals to Ig into G. That means we are not considering the R. If there is no R, simply I am telling here, if the potential limited up to Vg means here we are taking the only galvanometer, that's why. Here Vg is equals to Ig into G. Then in this case I am taking now this is the equation number 2 and V is equals to Ig into R plus G, this is the equation number 1. So from these two we are dividing 1 and 2, we are dividing 1 and 2. Then here what are, children? V by Vc, V by Vc is equals to what, right? V by Vc is equals to Ig into R plus G, R plus G by Ig into G, Ig into G. Ig cancel, then what we get? V by Vc is equals to R plus G by G. And in this case, let, children, V by Vg is equals to nothing but N. This is what? N. Then what, right, children? N is equals to R plus G by G. From that equation again we have to go for N is equals to R plus R by G plus G by G. Simply we are writing N is equals to R by G plus G by G. G by G means 1. N is equals to R by G plus G by G, and N is equals to here what, right? R by G plus 1. R by G plus 1. From that what have we, children? N minus 1 is equals to R by G. Clear? N is equals to R by G plus G by G, and N is equals to R by G plus 1. And from that what, right? N minus 1 is equals to R by G. From that what, right? R is equals to N minus 1 into G. So this is another form of resistance. R is equals to N minus 1 into G. So children, this is about the simply how we can convert the mcg into voltmeter. Clear children? So let's go for once. Very important question. How we can convert the voltmeter into the, how we can convert the mcg into the voltmeter? For that, simply when a high value of resistance of a resistor that should be connected in series with the galvanometer, then we will get, or we will create, or we will get, what is that? Voltmeter. Simply when a high voltage resistance should be, when high resistance is connected in series with the galvanometer resistance, we will get voltmeter. Again, this voltmeter should be connected in parallel to the circuit other components, with the other components. Look here, this is the galvanometer resistance and this is the value what we have taken, that is R. Now these two are in series. Now this can be taken as voltmeter. Clear? So this voltmeter should be again in parallel to the other components as shown in figure. Clear children? So after that, here we want to find out this R value. For that, when these two are in series combination, we will write expression should be like this: V is equals to I into R plus G, and V is equals to Ig into R plus G, because the current quantity are coming from the circuit that should be taken along through the galvanometer. That's we will write V is equals to Ig into R plus G, and from that equation what write V by Ig is equals to R plus G, and R is equals to V by Ig minus G, children. And next thing, if you will consider the potential only up to the Vc level or the galvanometer level, then we will write Vc is equals to Ig into G. Then V by Vc is equals to Ig into, dividing these two equations, then what we get? V by Vc is equals to Ig into R plus G by Ig into G. Ig cancel, we will get V by Vc is equals to R plus G by G. And we have to consider this term is N. Then N is equals to R plus G by G. And from that what we get, children? R is, okay. From that what we get? N is equals to, we are separating the terms, R by G plus G by G. This one. Here G gets cancelled, what we get? 1. Then N is equals to R by G plus 1. Then what you get, children? N minus 1 is equals to R by G, and R is equals to N minus 1 into G. So this is the way to how to answer the same question for 8 marks. And children, in 2 marks question, there is some most important question is there. What is the comparison between the ammeter and voltmeter? That's the most important question for 2 marks. While you are doing the practical exams also, they will ask in Viva questions like this. So children, difference between the ammeter, difference between ammeter and voltmeter. Children, comparison. Voltmeter. The first thing is, what's that? Ammeter can be used to find out the, what's that? Current. Clear? Ammeter is used to find out the current. And in this one, what it is? Voltmeter can be used to find out the potential difference. And second thing is, here ammeter must be have low resistance value, low resistance. So, and now only we discussed what's that? Voltmeter must be having some high resistance value, because it will take only less amount of current. Clear? And third one here, children, in case of ammeter, or for an ideal ammeter, resistance value is 0. Resistance is 0. But it is not possible in practical. Clear? There is no ammeter with the 0 resistance. And next, children, for an ideal voltmeter, resistance value is infinity. Resistance is infinity. Okay children, in practically it is not possible. Clear? First thing is, ammeter is the device that should be used to measure current, and it is a device that should be used to measure potential difference, and ammeter must be have low resistance, and potential difference must be high resistance. For an ideal ammeter, resistance is 0, but in practical there is no ammeter with 0 resistance. And for ideal voltmeter, the resistance is infinity. In practical there is no voltmeter with infinity value of resistance. And children, just now only I told you what's that, how we can convert. Simply we will add some 2 points here, and how we can convert MCZ? MC is converted to the ammeter by adding shunt. By adding shunt in parallel to the galvanometer. In parallel to the galvanometer. Clear? And in this case now, high resistance is connected in series. High resistance connected in series with what? Galvanometer. Yes. Clear children? Fourth point what it is? MCZ must be converted. How it is? Shunt is added in parallel to the moving coil galvanometer. Now it is ammeter. When high resistance is connected in series with the galvanometer, now it is voltmeter. And next point children, it is what? Ammeter is connected in series. Ammeter is connected in series with the other components in a circuits. Children, got my point? Ammeter is connected in series with the other components in the circuit. And now in this case, voltmeter is connected in parallel. Voltmeter is connected in parallel to the other components in the circuit. So children, so these are the main differences between the ammeter and voltmeter. Okay children, so I hope you understand. We will meet in the next video with some other interesting topic. My request is children, while you are watching the video, don't skip the video. You must be watched with very patience, and you have to watch any video last up to last. Clear? If you can like this video, subscribe my channel, share this video to your friends and your neighbors, and who deserve or who require this video to them, you must share it. Okay, bye, take care.